Hello dear students, hope you're all doing well. In this video, I will be talking about chapter 6, section 3, ionic bonding and ionic compounds. Let's start. Types of chemical bonding. We learned in section 2 there are two types of chemical bonding, molecular and ionic compounds. We learned that molecular compounds are made of a group of molecules. Look at here, imagine this is a drop of water. A group of H2O molecules together they make a molecular compound which is called water. Okay, and the bond, we said the atoms of molecules are held together by covalent bond. This is in H2O, the bond between hydrogen and oxygen. There are two hydrogens. Okay, the bond between hydrogen and oxygen, there are two hydrogen, they have bonded with oxygen. The bond between hydrogen and oxygen is a covalent bond because both of them, they are nonmetals, they share electrons. So we can say molecules are what? As we said, molecules that they are a group of atoms that held together by covalent bond. Means molecules are made of nonmetals. So a group of molecules together so they make a molecular compound. We learned this. So in the smallest units of molecular compounds, they are what? They're molecules. Here this is H2O. A molecule of molecular compound is the basic unit of molecular compounds. And we said we show the composition of the compounds by what? By molecular formula. Okay, we said molecular formula shows the types and number of atoms combined in a single molecule of molecular compound. It tells us, for example, the molecular formula of water is H2O. What does H2O tells us? Is a formula tells us that in a molecule of water there are two hydrogens and one oxygen. They have bonded with each other, isn't it? So molecular formula shows the composition of what? Of a molecular compound. But today's topic is about ionic compounds. Okay, ionic compounds, they're not made of molecules. They're made of, or is composed of, positive and negative ions that are combined together, Basha, and the number of positive and negative charges are what? Are equal. So here, for sodium chloride, Basha, ionic compounds are made of positive and negative ions, means that made of metal and non-metal atoms. When a metal atom loses electron, we learned that metals, they lose electron, non-metals, they gain. Metals, when they lose electron, they become stable. They're going to have octet of electrons. Non-metals, they're going to gain electrons to have octet electrons in their last shell. So metals like sodium, it becomes cation. Non-metals, they gain, they become what? Anion. So when a group of positive and negative ions together is called ionic compound. Okay, and number of positive and negative charge equals, here the number, here we have 8 positive, means 8 sodium cations, and 8 chlorine anion. So together, imagine this is a crystal of a piece of salt, that how they are arranged. Okay, so positive and negatives are equal. Now, what is the basic unit here? before we talk about basic units, what bond is between positive and negative ions? Ionic bonding. Ionic bonding is between metal and non-metal atoms, right? So here the bond between sodium, which is cation, and negative ions is called ionic bonding. But we said in molecules they are combined together by covalent bonds. Okay? Here, what is the smallest unit in ionic compounds? So ionic compounds they are not made of individual particles. Like for molecular compounds, they're made of individual molecules, right? Individual particles, which are called molecules. But here, they're not made of individual atoms because, or particles, we mean, because they have all bonded with each other. Look, there's like a chain, a network. For example, this positive bonds with this negative, this chlorine bonds with this sodium, this sodium bonds with this chlorine. At the end, it's like a chain. Look, so you can't indicate the smallest unit. So how do we indicate the smallest unit? We say the smallest units are formula units. What's the formula unit? Formula unit shows the ratio of ions in an ionic compound. The ratio of ions in an ionic compound. Here, look at for sodium chloride. The ratio is what? We have 8 sodium and 8 chlorine. So 8 sodium cation, 8 chloride anion. So the ratio is the small, if we make it simpler, is going to be 1 to 1, the ratio. For each sodium, there's a chlorine. For each chlorine, there's a sodium. The ratio of ions is 1 to 1. So the smallest whole number ratio is 1 to 1. So if I write the formula unit, I'm going to write like that. Sodium Na NaCl. So NaCl is the what? Is the ratio of ions in ionic compound of sodium chloride. Okay? That's it. But the ratio of ions is not always 1 to 1. How it depends on the charge of the ions combined. How? Example, to achieve electrical neutrality in ionic compound of calcium fluoride. Look, calcium, guys, calcium, it's in group 2. It has 2 valence electron. Pasha. If it bonds with fluorine, fluorine has how many valence electron? It's in group 17. 17 minus 10 tells us the valence electron, which is 7. Bash. When a calcium, which is metal of group 2, bond with fluorine, what happens? Which one is going to lose electron? Metals, they lose electron, non-metals, they gain. So when they bond, there will be ionic bonding. Bash. We're talking about how ratio of ions or charge of ions affect the ratio, affect the what? The formula unit. Bash. Calcium, guys, look, it has how many valence electron? It has 2 valence electron. To become 8, okay, to become 8, it needs to lose its 2 valence electron, right? Okay, this is the valence electron. So that's like that. And chlorine, it has how many? 7 valence electron. To become 8 needs 1 electron. Calcium, to become 8, is going to lose that 2 valence electron. We know it's in the third shell there are 8 electrons. If it loses that 2 electrons, calcium is going to have 8 electrons in the last shell. That's why we learned that in the octet rule, atoms, they lose, they share, they gain electrons to have 8 valence electrons in their last shell. So calcium, how is going to have 8 valence electron if it loses 2 electrons? Bash. So, and fluorine can get only 1 electron, needs 1 electron. So each fluorine can get only 1 electron. So the charge of calcium when it loses 2 electrons is going to be 2 positive. Okay, 2 positive. And what about chlorine? Chlorine is going to be, when it gets 1 electron, 1 negative, right? Because fluorine, to become 8, to have 8 valence electron, needs 1 electron. So when it needs 1 electron, its charge is going to be 1 negative. So the charge of fluorine is always 1 negative. Charge of calcium is always 2 positive to become stable. Now, when calcium bond with a fluorine, a fluorine can get only 1 valence electron of calcium. But calcium must lose 2 electrons, and there must be another fluorine to get that electron. So here we must add another fluorine. Okay, that each fluorine has. So this electron will be lost and will be transferred to fluorine. Fluorine gains this fluorine can get 1 valence electron. Calcium must lose 2 electrons. So this fluorine gets that electron, okay, will be transferred to that, it will be paired with this. So how is going to be? This is going to be calcium will get 2 positive, fluorine with negative, like that. Now fluorine has 8, and which is charged 1 negative for this fluorine, plus this fluorine also, it has how many valence electron? Now after getting 1 electron from calcium, 1, and its charge is 1 negative. Bash. Now for each calcium there must be how many fluorine? 2 fluorine. Because calcium loses 2 electrons, there must be 2 fluorine. Why not only 1? Because each fluorine can get only 1 electron. Why we do it like that? We can say in other words, charge must be equal. It's 2 positive here, 1 negative plus 1 negative here is 2 negative, right? 2 negative. So charge must be equal. Look at the definition. Number of positive and negative charges are equal, okay, in ionic compounds. Now the charge equal. But if I write the formula unit, how am I going to write? So for each calcium, there are how many fluorine? 2 fluorine. There must be. Otherwise, charge will not be equal. If I write formula unit, so I write calcium, its symbol, and there are how many fluorine? There are 2 fluorine. That's why this is the formula unit of calcium and calcium fluoride ionic compound, the ionic compound of calcium fluoride. This is how we write formula unit. Why we don't write just calcium and 1 calcium and 1 fluorine? Because if we do it like that, charge will not be equal. Okay, charge must be equal. So for each calcium we have 2 fluorine in an ionic compound of calcium fluoride. Okay, because then charge must be equal. For example, NaCl. Does NaCl conduct to electricity? No, because number of positive and negative charges are equal. The charges are equal, so they cancel out each other. Then they don't conduct to electricity. But when they dissolve in water, they can conduct to electricity. Okay, so most ionic compounds exist as crystalline solids. Okay, and they're like crystal. Look at this figure. They're like what? Crystals. A crystal of ionic compound is 3-dimensional network of positive and negative ions mutually attracted to one another. This 3-dimensional arrangement of ions, okay, positive and negative ions that mutually attracted to one another. Okay, so you must know what you must know. Ionic compounds, they are made of a group of positive and negative ions. They are bonded with each other. It happens between metal and non-metal atoms. Metals they lose, they become cation, and metals they gain, they become anions. A group of positive and negative, they form an ionic compounds, and number of positive and negatives must be equal, like calcium and fluoride. For each calcium, there must be two fluorine, two charges become equal. The bond between them is ionic. The smallest units of ionic compounds are formula units. Formula units are the ratio of ions. It's not about the smallest particle, it's about the ratio. The ratio tells us that we are going to find out the ratio of ions, small whole number ratio of ions. Then the ratio will be smallest unit, which is called formula units, and the ratio of ions depends on what of formula unit, or we can say formula unit depends on the charges. Like we did this example, like for calcium's charge is 2 positive, there must be 2 fluorine, and we write the formula unit like that. Okay, formation of ionic compounds, guys. We know electron dot notation. Normally, usually we use it for molecular compounds, for molecules, and we used Lewis structure to write the electron dot notation of molecules, to how to explain the formation of covalent bonds between the atoms of molecules in molecular compounds. We can also use electron dot notation to explain the formation of ionic compounds. There are 2 examples, there are not more. Also, we have some question in the section review and chapter review. So let's talk about how we can use electron dot notation. It's not very common to use electron dot notation for formation of ionic compounds. So there are 2 examples how we explain. First of all, individual before bonding, sodium has one, it's sodium atom, neutral atom, and chlorine atom. Before bonding, chlorine has 7 valence electrons, sodium has 1. Okay, this is how we use electron dot notation. We write this symbol and a dot. Chlorine, how we write, it has 7 valence electron. We write 7 dots around the symbol. Okay, now it's electron dot notation for 2 individual atoms of sodium and chlorine. But after bonding, what happens? Sodium, here look, when they combine together, when they get together, sodium is a metal, it loses its valence electron. Sodium has 1 electron in the last shell, in the 3rd shell, and second shell it has contains 8 electrons. So if it loses that electron, it's going to have 8 valence electron in the last shell. Then it's going to follow the octet rule. It's going to be stable. Okay, its potential energy will be decreased. And chlorine has 7, it needs 1 electron. At this time, what happens? This electron transfers to chlorine. And sodium loses, chlorine gains. This is how we use electron dot notation. Then if it loses the sodium, now it would be ion, and because it has lost only 1 electron, the charge will be 1 positive, plus chlorine, it has gained 1 electron. Okay, so it has gained 1 electron. Now the dots will be 8, right, the valence electron, and this chart tells us that the chlorine has gained 1 electron. This is the electron dot notation to demonstrate the formation of an ionic compound, or the formation of ionic compound of sodium chloride. How sodium and chlorine they make an ionic bond. So at this time, if we write formula unit for each sodium, there is one chlorine, so we write the formula unit. Formula unit, you don't put charges, okay? That's it. For each sodium, there is a chlorine. Okay. But for when combination of calcium and fluorine, we write the calcium is in group 2, it has 2 valence electron, 2 dots. Fluorine, it has 7 valence electron. But as we said, calcium loses 2 electrons, right? The charge will be 2 positive after losing. So it must lose 2 electrons. Each fluorine, we said, can get only what? 1 electron. So look, this one passes to this fluorine. It will be paired with this unpaired electron. And there must be another fluorine. We must add another fluorine to get the other valence electron of calcium. Now calcium after losing will be 2 positive, and each fluorine is going to have 8 valence electron in the last shell, also calcium after losing, and another fluorine also will with 1 negative. If we don't write 1, we mean 1, okay? So now the charges are equal, 2 positive and we have 1, 2 negative. Charges are balanced. For each calcium there must be what? 2 fluorine, isn't it? So the formula unit will be like that. What this formula unit tells us? Ratio of ions in an ionic compound. Okay, that's it. This is how we use electron dot notation to explain the formation of ionic compounds. Characteristics of ionic bonding. Look, in this slide, we're going to talk about how ions are arranged in a crystal of ionic compounds. Ionic compounds, they are crystalline solids. But how they are arranged? They're going to arrange in a way, in orderly arrangement, Basha, known as crystal lattice. They're going to arrange orderly. This orderly arrangement is known as, we call crystal lattice. This is the name of the arrangement of ions in what? In ionic compounds. Why they arrange like that? Ions minimize their potential energy by combining in orderly arrangement known as crystal lattice. Or we can say, what's crystal lattice? Three-dimensional arrangement of ions. The arrangement of ions in 3 dimension of group of ions in a crystal of a ionic compound. Okay. So look, this is for sodium chloride. Look, this is the crystal lattice. This is the arrangement of sodium and chlorine ions in a sodium chloride ionic compound of sodium chloride. For example, look, the arrangement of sodium chloride. Basha, how are these ions of sodium and how the sodium and chloride ions arranged, okay, in a crystal? Or how is the crystal lattice of sodium chloride? We can use these words, Basha. Each sodium cation is surrounded by 6 chloride anions in the crystal lattice of sodium chloride. How the ions are arranged? Look, it says each sodium, okay? Look, this is the sodium. Each sodium is surrounded by this is chlorine. By what? By 6 chlorine or chloride anion. 1, 2, 3, 4, 5, 6. At the same time, each chloride, okay, anion is surrounded by 6 sodium cation. This is the arrangement of ions in 3 dimensions. Okay? The 3-dimensional arrangement of sodium and sodium chloride is like that. Okay? In a crystal lattice. This arrangement is called crystal lattice. Okay? That's it. This is the arrangement of ions in a crystal of crystal lattice. The arrangement of ions called crystal lattice. Crystal lattice is the arrangement of ions in ionic compounds. But this arrangement changes. And strengths also change. For example, the bond between sodium and chloride, calcium and fluoride, the strength is different. The arrangement also will be changed. Why? Because of the size of the atoms, ions they have. Combined charges. For example, calcium here, calcium fluoride has calcium, its charge is 2 positive. Fluoride, there must be 2 fluoride, isn't it? We said for each there are 2 anions for each cation, right? There must be 2 fluoride, right? Okay, this is calcium. Let me erase this. Calcium, we said calcium fluoride. So for each cation, for each calcium, there must be 2 anions, 2 fluoride. Okay, so the charge numbers, there are 2 fluorine, but in sodium, the number is 1 to 1, right? The number. But here is number for each cation, there are 2 anions. So this is charges, number of ions, they affect the what? The arrangement. For example, in calcium fluoride, there are 2 anions for each cation, okay, in total. But how is the arrangement? It says each calcium cation is surrounded by 8 fluoride anion. At the same time, each fluoride ion is surrounded by 4 calcium cation. Each calcium, look, each calcium is surrounded by 8 fluoride anion, and each fluoride anion is surrounded by each fluoride anion is surrounded by 4 each fluoride cation, if anion is surrounded by 4 calcium cation. This is the arrangement of ions, the arrangement of calcium and fluoride anions in 3-dimensional arrangement, okay, in 3D. And this arrangement of ions is called crystal lattice. Okay, that's it. Comparison of ionic and molecular compounds. In this slide is about the property, the characteristics, the difference between characteristics of ionic and molecular compounds. State at room temperature. Ionic compounds, they are crystalline solids, example like salt. But molecular compounds changes. Sometimes liquid like H2O, water, right? Water. Sometimes is gas at room temperature like carbon dioxide is a molecular compound. CO2, they are all nonmetals and it's a molecule. And solid sugar, C6H12O6, right? It's a type of sugar. Sugar is a molecular compound. C6H12O6, they are all nonmetals, and a group of nonmetals that are covalently bonded with each other. This is a molecule, a group of molecule of sugar makes a sugar compound. But crystalline solids, for example, NaCl, right? NaCl, if I ask in the exam, NaCl is ionic compound or molecular compound, you say NaCl is the formula unit of what? Sodium chloride compound, ionic compound. We know sodium is metal, chlorine is non-metal, so the bond between cation and anion, metal and non-metal is what? It's called ionic compound. Okay. Bond strengths. Actually, ionic compounds, the bond between ions is stronger the bond between atoms of what? Atoms of molecules in molecular compounds. boiling point and melting point. You know, boiling point and melting point. Boiling point is the temperature that liquid changes to gas. Melting point is the temperature that a solid changes into liquid. Okay, ionic compounds, they have high boiling point and they have high melting point, needs high temperature to be boiled to change to gas. It needs high temperature to change, if it's solid, to change into liquid. But generally molecular compounds, they have what? Low melting and boiling point. Solubility in water. Ionic compounds, they have high solubility in water. High amount of, example, salt dissolves in water. Okay, solubility is about ability of a substance to dissolve. Okay, here is about solubility in a liquid water, how they dissolve, how much. So they have high amount of ionic compounds, they dissolve in water, but molecular compounds low generally. And hardness and brittleness, actually ionic compounds, they are hard, but if you try to hit it, try to bend or something like that, it breaks easily, but so they are hard but brittle. But molecular compounds depend on compounds. Okay, it's not about a change with the compounds, type of compound. Conduct to electricity. Ionic compounds, they do not conduct to electricity when they're solid, but conduct to electricity when dissolved in water. Like salt. Salt, if you dissolve in water, then it carries electrical current and it conducts to electricity. Why? Why salt? Look, this is salt is made of a group of ions. They have bonded with each other. This is salt, and the arrangement is crystal, and the ions are not free, but when they dissolve in water, after dissolving in water, what happens? The molecules break the bond between cation and anions, positive and negative charges, and then the ions become free. They move freely throughout the solution. Okay, in the mixture. When they can move freely, they can carry electrical current. Why? Because ions can move freely to carry electrical current. Here I have explained why, and when they dissolve, I have explained this, that when they dissolve in water, their ions separate each other from each other, become surrounded by water molecules. These ions are free to move throughout this solution, as I mentioned. So such solutions are electrical conductors, but not all ionic compounds they can conduct to electricity. No, some of them they do not conduct to electricity because they do not dissolve in water. Why? Because the attraction between water molecules and ions cannot overcome the attraction between ions. We have positive and negative, but the attraction between water molecules and ions is not more than the attraction between ions. So water molecules, we can say, cannot break the bond between positive and negative ions. So molecular compounds, they do not conduct to electricity. They are not made of ions. So if they conduct to electricity, very small amount. So polyatomic ions, monoatomic ions. Guys, when an atom loses, when an atom gains electron, what happens? The atom becomes what? Becomes ion. Ion means having a charge. When you see a symbol of atom, Pasha, and you see a charge can be positive, can be negative. For example, for sodium, lose one electron, it becomes ion. It's going to have a one positively charged ion. chlorine is going to have a negatively charged ion. So when a single atom, only one atom, has a charge, it's called monoatomic ion. That's easy. What about polyatomic ions? When a group of covalently bonded atoms has a charge, it's called polyatomic ions. Look, pay attention. It says a group can be two or more atoms, but covalently bonded atoms. Covalently means the atoms, a group of atoms must be what? Must be nonmetals. And they must have a charge. Example, NO3, nitrogen is nonmetal and 3 oxygen. They have shared electrons with each other. This is the Lewis structure of polyatomic ions. Nitrate. This is nitrate what? Polyatomic ion. 3 nitrogen, 3 oxygens. They have bonded with nitrogen. Now, 1 electron has gained. When 3 oxygens and they have bonded with nitrogen, when they share electrons, all of them, they must have 8 valence electron. So, but when we know if they don't gain 1 electron, one of the oxygen is not going to have 8 valence electron. So what happens? They must gain 1 electron. So they're from another compound, another atom, another molecule, or another polyatomic ion, they're going to what? They're going to gain 1 electron. Okay? So when they gain 1 electron, as a whole, okay, we say that 1 electron has gained. 1 electron has is gained, we don't know where. It's not important. What's important that NO3 has it as a whole has a charge, means in the formation of the nitrate ion 1 electron has gained. Okay, why? Because to all have 8 valence electron. Look, each oxygen has 8, 2, 4, 6, 8. 2, 4, 6, 8. Nitrogen, also nitrogen must have 8. 2, 4, 6, 8. 2, 4, 6, 8. How we know when electron has gained? Bash. Each oxygen has 6 valence electron. 3 times 6, 18. Nitrogen has 5 valence electron. Total must equal 23. Because before bonding, each oxygen has 6. Nitrogen has 5. But when they bond, what happens? Look, how we know? Let's count the number of valence electron in this ion. 2, 4, 6, 8. Okay, 8. 8, 10, 12, 14, 16, 18, 20, 22, 24. We said that the total must equal 23. We understand that 1 electron has gained. To all have 8 valence electron. Okay, in ammonium, each hydrogen has, in this ion, polyatomic ion, let's count before bond with each other. Each hydrogen has 1, so 4 valence electron. Plus nitrogen has 5. 4 plus 5, 9. There must be 9. But here, look, 2, 4, 6, 8. Means 1 electron has lost. This is called polyatomic ion. They have shared, the bond between these atoms, this group of atoms, is covalently bond. But as a whole, 1 electron has gained, 2 electron or more means, or an electron has lost, like that. So polyatomic ion is a group of atoms, of covalently bound atoms. They have a charge. As a whole, we don't know. This positive is not the positive, it's not hydrogen. It's not about that nitrogen has lost it. As a whole, in this molecule, 1 electron has lost. Why? Because if now all stable. Each hydrogen has 2 valence electron, isn't it? Each hydrogen, and nitrogen has 8. So they don't need, that electron is not necessary there. Okay, that's it for sulfate. Iron also is like that. As a whole, this group of atoms, they have gained 2 electron to all have 8 valence electron in the last shell. You must know the examples, and sometimes we write like that, okay, as a whole, to explain that, to show that the group of atoms as a whole has a 1 positively charged. Monoatomic ions is also important, and polyatomic ions, opposite charges of opposite charges, combine together to form ionic compounds. Na is not a monoatomic ion, is a ion, and also this ion, but this is polyatomic ion. Polyatomic ion means 2 or more atoms, there must be a charge. When they combine, because ionic compound is made of a cation and anion, so there's a cation and anion, they must be opposite charges. Not this is negative, the other one is negative, no, because one loses, one gain. Sodium loses 1 electron, NO3 as a whole, they gain it. Okay, this is how NO3 has made. So then when they combine, NaNO3, okay, sodium nitrate will be produced. That NaNO3 is a formula unit of sodium nitrate compound, which is ionic compound. But NaNO3 is the formula unit, you don't write these charges. Okay, that's it. This is the end of the video. Okay, you can check, they're easy. Thank you so much. Inshallah, next time I will talk about chapter 6, section 4, metallic bonding. Okay, see you next video. Bye.